Hey, these are notes 3.6. We're now talking about observational studies versus experiments. We've talked a lot about observational studies. We'll talk just a little bit about that, but mostly about experiments today. We're going to explain the concept of confounding, okay, and how it limits the ability to make a cause and effect conclusions, especially in observational studies. And then explain the purpose of comparison in an experiment and placebo effect and blinding in the experiments. Okay, so we'll think about these things. So we kind of talked about a little bit before about observational studies. We can't really say there's cause and effect, whereas experiments, if they're well designed, we can have a cause and effect relationship, and this is the reason why. Okay, so we read a little in 3.1. There was a problem we did that about if they did a study, I think it was USA Today or something like that, some magazine or newspaper did a study, and they found that if people eat with their family at least 5 times a week, they're more likely to get better grades. Okay? Does that mean that just because people ate 5 times a week with their family that they will get better grades? Is there a cause and effect to that? No. Okay, and we talked about no, there's other reasons, right? So just because people ate together, maybe they're less likely to have a part-time job or full-time job. They might be less likely to participate in extracurricular activities. They might have more time to study, okay? Therefore, they might get better grades. Those that do not eat together, maybe they have a job. They're not able to. Maybe they're in sports or other activities like musicals or something, and they're busy and they don't eat with their family, and then they have less time to study. So is it because of their eating, or are there other factors that go into the grades? Okay, definitely other factors. Now, when we can't decide if it's because of our explanatory, which in this case was eating 5 times a week, if we can't decide if it's that or another variable, we say that the different variables are confounded. Okay? So confounding, definition of confounding, when two variables are associated in such a way that the effects cannot be distinguished from each other. So the response that we got, right, the results that we got, are they because of this variable or because of that variable? If we don't know, we have confounding. Okay? And that's how observational studies are. Observational studies cannot definitively show a cause and effect relationship because we don't know if it's because of that explanatory variable that we're getting this response. It could be a lot of different things. Here's an example. A study of more than 4,700 children, researchers from Cincinnati Children's Hospital found that children whose mothers smoked during pregnancy were more than twice as likely to develop ADHD as children, okay, when moms didn't smoke. Based on the study, can we conclude that a mother smoking during pregnancy caused the increased risk of ADHD? Okay. Now, was this an observational study or an experiment? Okay, it was an observational study, right? We just observed whether mothers smoked or didn't smoke, okay? And then we observed if their kids had ADHD or not, okay? So we can't say there was a cause and effect, okay? We can say there's an association between them, but we don't know that one caused the other. Smoking increase may have increased the risk of ADHD, but it's possible that there's other factors. Like all the women who smoke, maybe they all have more unhealthy diets than the people that didn't smoke. They could have, there could be other things in their lives, other factors that are true for smoking mothers versus non-smoking mothers, other than just the smoking that caused that ADHD. Okay, so we have confounding. I don't know if it's because of this variable or because of that variable. Okay. So one way to eliminate those is to eliminate the confounding, is to do an experiment. Okay. Now with the smoking mothers, it's not ethical, but in an experiment, we would have the people that are willing to participate. We would say, you ladies, randomly, you guys have to smoke, and you guys are not allowed to smoke. So when we do that, hopefully we get, so if the other variable is an unhealthy diet, hopefully we get some people in an unhealthy diet here and here. So we'd get a mixture. All the other variables would be mixed in, okay, into both groups. So the only variable that's different between them would be the smoking and the not smoking, okay? Then we can see the cause and effect then after that. So we try and even out all the variables in both groups so that this is the only difference between them, okay? And that's an experiment. Okay, an experiment, remember we give a treatment, okay? We randomly assign a treatment, okay, in this smoking versus non-smoking. Then we have the treatment being applied to the experimental units. Now, when it's people, we usually call them the subjects, but the experimental units could be, trees or whatever we're doing the experiment on, okay? So let's look at this one and see if this is a good experiment. Have each student measure his or her, we want to know if, the statistical question, does caffeine have an impact on our pulse rate? Okay, so when you take your heart rate, does caffeine have an impact on that? So we'll have each student measure his or her initial pulse rate. We'll give students a soda to drink. We'll wait a little bit of time for it to have an effect, and then have each student measure her pulse rate at the end. We'll compare their before pulse rate to their after pulse rate. Is that a good experiment? Okay, not very good. Are there other variables that could, besides the soda, that could have an impact? Okay, if this is done in a classroom, maybe something happens right before they took their pulse rate and it brought everyone's pulse rate up. Maybe there was so we don't really know. There's other variables that could be there. Also, in this soda, maybe the sugar had the impact, and it wasn't the caffeine, but it was the sugar that had the impact on their heart rate. So it could be different variables, okay? So this is a way to remedy that, to make this better. We can have a control group. A control group is a group that provides a baseline for comparing. So if we have a group that doesn't get anything, and we get a group that do get the treatment, then we can compare those two groups, okay? So we would have a group with the soda, and we would have a control group with no soda, okay? Or more specifically, with caffeine and with no caffeine, okay? So then we could take this group and compare it to this group. And hopefully the only difference between the two groups is whether they had the caffeine or not, okay? So everything that's happened and the sugar intake and stuff like that, we want to all be the same. So what we can do is we can give this a no caffeine soda. So these people get a caffeinated soda. These people get a Coke, and these get a caffeine-free Coke, but it still has the sugar in it, okay? So all the other variables are the same except for the caffeine intake. And then we can compare those two groups. So the control group is a group that gets no treatment, okay? It gets no treatment. Okay, so here's an example. Many utility companies have introduced programs to encourage energy consumption, conservation among their customers. So the energy companies want people to use less electricity, okay? So they want to do two things. They are considering placing digital displays inside households to show the current usage and how much money that costs, okay? So we have one group with a display inside their house that shows their costs and how much energy they're using. Okay, that's one group of people. A cheaper approach is to give customers a chart and information about monitoring their usage from their outside meter. Okay, so there's another group that they want to monitor their own mirror with a chart. Okay, so they get their own chart and they want to monitor their own consumption and how much it would cost. Okay. So they conduct an experiment to compare these approaches, the display versus the chart. Now, should we also have a control group? Okay. So let's say we did not have a control group in here. We just compared the display group versus the chart group. Do we know if their energy consumption even went down? Okay. So maybe if we could maybe compare them to like last year, like how much energy they used last year. But last year, the weather might have been different, right? They might have had a warm January versus a colder January to display. So it'd be better to have a control group. So within the same period of time, we look at these people and how much their energy consumption changed. We look at this group and how much their energy consumption was. And we look at this group who didn't have anything. They were just living normal life and how much energy they used. Then we can see if energy consumption was reduced in one of these groups. Okay? So if the control group, just the normal people living, used, I have no idea, 200 whatever, and these people used 150 and these people used 100, we can tell these two groups reduced their energy consumption compared to doing nothing. Okay? So that's why we have a control group. It's our baseline data of people doing nothing with no treatment. Okay? You've probably also heard of a placebo. Okay? So in the experiment, SOTA, we used comparison to help prevent confounding. It still could be that if you look at this group that had caffeine, maybe their thoughts, like if they knew they were getting caffeine, maybe their heart rate would increase just because they thought they were getting it. Okay? Some people, in a lot of studies with pills, okay, for drug companies, they give people the real pill, the treatment, okay, with the active ingredient, and then they give other people a treatment with no ingredient. Okay? So the people with the ingredient, they compare them to the people without the ingredient, and then they see, does this drug really have an impact? Okay? So if everyone thinks they're having the drug, then there's no confounding there. If people just got the treatment with the ingredient, and then we had a control group, sometimes just thinking you have a drug has an impact on how you perceive things. Okay? Let me say that again. Sometimes thinking you have it, even if you don't, has an impact on your result. Okay? So that's the idea of a placebo. The placebo effect describes the fact that some subjects in an experiment will respond favorably to any treatment, even if they're not really getting the treatment. If they think they're getting the treatment, they're going to respond favorably. Okay? And the placebo is just what they get. They're getting something with no active ingredient with it. Okay? They're getting a sugar pill, sort of to say. Okay? So do placebos work? Okay? So there's some different things here. They did one study and found that 42% of balding men maintained or increased the amount of hair in their head when they took a placebo. Maybe I should take a placebo. Okay. In another study, they zapped people's wrists, 24 people, with a painful jolt of electricity. Sounds like fun, huh? Then they rubbed a cream on it. Some people had an active ingredient, other people didn't. Actually, in this case, they're testing the placebo effect. They rubbed the cream with no active ingredient in it, but they told them it should soothe the pain. It should make it better. And then they zapped them again, and a lot of people said that there was less pain just because they were told that there should have less pain, even though there was no active ingredient. Okay? That's the idea of the placebo effect. Okay? They also said, some experts, this is kind of controversial, I think, but with depression, some experts say that when people get a placebo, when they think they're getting a drug, they said that 3/4 are improve when they're just thinking about getting the drug. Others very much disagree with that. In any case, placebos work. Okay, in some places, placebos, when you get a placebo and you think it's working, you improve. Okay. So here's an example of it. Okay. Some people with chronic pain use magnets for healing. So they took 50 patients, And a doctor identified a pain where they had it, whether it was in their back or shoulder or wherever, and they asked them to rate their pain. 1 to 10, where's your pain? Okay, how severe is it? Then the doctor selected from an envelope containing a magnet at random. Okay, some of those magnets were active, were actually magnetic, and others were not active. They were not magnetic. Okay, the chosen magnet was then applied to the site on the person for 45 minutes, and after being treated, each patient was asked to rate their pain again. So, did their pain improve, get better, stay the same? So the patient didn't know what type of magnet was being used. Okay, either did the doctor. Okay, so why is that important? Okay, so from the placebo effect, we know that if people get a treatment, whether it's an active magnet or not an active magnet, a lot of times they feel like they're getting improvement just because something's happening, even though nothing is really happening. Okay, so if they know they're receiving, researchers might not know if the improvement was due to the magnets or because of their expectation that the magnets was going to work. So therefore, they do a blinded experiment. Okay, so if it's a single blind experiment, only the subject that they're working on doesn't know which treatment they're getting. So in this case, if the doctor knew what treatment they were getting, but the patient did not, that would be called a single blind experiment. In this particular one, the doctor just randomly chose. He didn't know if the magnet was active or not, and the patient didn't know if it was active or not. That's called a double-blind experiment. Okay? Now, double-blind experiments are important sometimes because of this idea. Let's say a doctor has 2 treatments they could give people. Okay? They could give treatment A, and they could give treatment B. Now, the doctor thinks that treatment, or let's just call it a control group, okay? So they could give a placebo, or they could give an active ingredient thing. Now, if a doctor knows, and he's prescribing one of these 2 things, if he has a patient come in, patient number 1, he sees patient number 1, oh, I feel really bad for them. They're really hurting. They really need some help. If the doctor knows which one it is, he's gonna want to prescribe the medicine to him because he wants them to get healed. If he sees patient number 2 and says, "Oh, they're not too bad. I think they would be okay without the ingredient," then they're in the control group. So that this creates confounding. The doctor is giving them based upon the health of what they start with. Okay, that's a problem. So a double-blind experiment, the doctor doesn't know what's being prescribed to them, and the patient doesn't know which they're getting as well. Therefore, we have 2 groups where the other variables are the same. The only difference is whether they're getting the treatment or not getting the treatment. Okay, so single blind if just the patient doesn't know, a double blind if the patient or the doctor, okay, person, or it doesn't have to be a doctor, but yeah, doesn't know. Okay, so single blind and double blind. So an example, does taking aspirin help protect people against heart attack? Physicians Health Study 1 a medical experiment was to help answer this question. So they took almost 22,000 physicians, males. Half of these subjects took an aspirin every day, and the remaining took a dummy pill that looked and tasted like aspirin, but there was no aspirin in it. Okay? So they took a placebo. After several years, they got results, and 239 of the control group had a heart attack, and 139 of the aspirin group had a heart attack. So the aspirin group definitely had less than the people that took the placebo. So did the aspirin work? Okay. The difference is large enough to say there is convincing evidence that aspirin works. Okay, so there's a big difference there that aspirin does work. So answer these questions. Why was it necessary to do an experiment rather than simply asking the doctors whether they take aspirin or not? Okay, so if we just ask them, that's an observational study. If we just ask them, okay, but do we really know, was it because of the aspirin Or was it because of some other factor? Like maybe those that are more likely to take aspirin also take better health of themselves. They eat better and so forth, okay? So we can't do an observational study to have this cause and effect. It needs to be an experiment, okay? So they took these almost 22,000 people. They split them into two groups randomly. Some people had the aspirin and some people had the placebo, okay? So that's why because then we can see a cause and effect, okay? So that's why we can't simply just ask them whether they took an aspirin or not. We have to assign it to them. Explain why it is necessary for the experiment to include a control group that didn't receive aspirin, okay? If we just gave and figured out how many people had aspirin, that wouldn't really help us to compare it to anything. Does it better? So we had to have a group that had a placebo to compare it to. So then we can see, does it really make a difference? So that's why we have to have that control group for comparison reasons. Was blinding used in this experiment? Now, they don't really tell us very much here, but I think so. Because I don't think the physicians knew if they were getting the aspirin or the placebo. Because it says some of them took aspirin and some of them took a dummy pill that acted and tasted like it. So I don't think they really knew. So I think blinding was important here. So those doctors who had a heart attack or not, they were blinded as to which one they got. Okay? All right, so we talked about confounding, and confounding with the experiment, we don't have the confounding if we set it up right, because we have other variables in both groups, so we narrow it down to only the treatment. Okay, so cause and effect is, we can say it is true, or can be good in an experiment. Comparison, we need that control group to compare to, okay, to make comparisons. And the placebo effect, we give the placebo effect to negate people just thinking they had a treatment, and also the blinding to helping even out responses so that everyone, so the results are accurate